In this video, we'll talk a bit more about bonding and coating. So how we actually attach the strain gauges to our device and how we protect the strain gauges when it's attached to the device. Now, you've already seen the video, a sample video of how strain gauges can be applied. And hopefully you learned a bit from that practical demo of how it can actually be done. Well, it depends really on the material. And so different materials will have different ways and different nuances around attaching our strain gauge. So here's some steps for attaching our strain gauge to metal, and here's some steps for attaching our strain gauge to concrete. And you'll notice one of the common themes there is preparation. We want our material that we're attaching our strain gauge to be nice and clean, free of dust, free of grime and oils and things like that, because we want our strain gauge to bond really well to our actual surface material. Now, of course, we also want to have elements of actually soldering wires to our strain gauge and then obviously connecting it up to our circuit so we can actually measure what's coming off the strain gauge. There's a number of different ways we can attach our strain gauge to whatever material that we're dealing with. The most basic way of attaching it is probably with CA glue, also known as various forms of super glue. And these CA glues have a really quick curing time. We're talking about under a minute to actually cure it. And one of the nice things about them is there's no mixing required. You essentially put it on, push it down, hold it down for a little bit and pull it off, and we've got our strain gauge attached and it's being used. Now, there's pros and cons about this sort of approach. Pros and cons around temperature and fixability and how strong these super glues are compared to some of the other approaches we've got. But there's certainly a ease of use factor and a quickness factor in using this super glue approach. There's also polymer-based approaches where we're mixing two different ingredients together to produce a strong polymer glue. And these can be good, particularly in strong alkaline environments. And we might have some materials that we're using that break down or might attack the strain gauge or might have lime coming out of concrete or something like that, which may affect our bonding if we're using a super glue style approach. And these polymers can offset some of that and are resistant to it. One of our other common approaches is using an epoxy resin based approach where we have a two-part epoxy resin. It takes longer to cure. They say even with 5-minute resins, it takes 24 hours to reach a full strength there. But this produces our best chemical resistance and is quite strong and adheres very well to a wide variety of different surfaces. But once again, preparation's key. We need to clean these surfaces down, make sure we're not adhering our gauge to the dust that's on the surface, but the actual surface itself. So we want it to be nice and clean. Now, other important thing is how do we protect our gauges once they're actually on the surface? And there's a bunch of different coatings you can apply to actually protect the gauges. Now, if we're using a gauge in a lab on a piece of equipment and we're just putting it on there, doing a few measurements, and we might not need some sort of a coating there. We might just leave it as it is. But if we're using these in the field and putting them on a building or a bridge or some sort of structure, or using them in a dusty or dirty environment, or an environment where they might get damaged, we will definitely want to coat them and protect them. So these coatings and protections allow us to protect against chemical resistance, issues of electrical resistance or conductivity, make them more thermally stable, so we've got a bigger thermal mass around our strain gauge, helps these strain gauges to be stable over time, and essentially protects them. Now, there's a number of different coatings we can apply, from wax-based coatings to try and keep out moisture from our strain gauges and electrically isolate them from different things, to neoprene or rubber-based strain gauges. And these aren't, you just stick a bit of rubber over it, you actually paint on rubbers. They're solvent-based and allow us to reduce the effects of moisture and electrical isolation as well. There's tapes that can be applied over the top of these strain gauges, which are probably one of our easier things to apply. There's silicone that we can apply to it. Some of these silicons we can paint over them, or we can add extra epoxy over the top of our strain gauges to protect them, which have really good chemical resistance properties around them. But they can also make them quite stiff and mean it's difficult to measure some of our strains that we're actually getting within our material.